Chapter 6 starts talking about radicals and roots. It's going to be an overwhelming topic for this chapter. When we take a number and raise it to a power, okay, so here's the number, the base, and I'm raising it to some power, and I get some number. So like 2 raised to the third power is equal to 8, okay? You can undo the inverse, essentially, of taking a number and raising it to an exponent is using that root, which is what we call the nth root. Now, to undo it, we do that to the bigger number to get back to the smaller number. What I mean by this is, and this was the example we used in class today, if we have 2 raised to the third power, that's 8. And if I wanted to go from the big number back to the smaller number, if I wanted to undo the exponent, what I would do is I would take the third root of 8. That undoes the power, and it would get me the number 2. That is the new power, okay? Number raised to a power gets me a big number. Big number with that root, same number, gets me back to the original number. It's their inverses. The next part of your notes talks about the types of roots you will have. You will either have one real root, no real roots, or 2 real roots. When you have 2 real roots, all you have to remember to put on your notes is a plus or minus in front of that number. For example, the square root of 4, well, I know the square root of 4 is 2, but we can also say that the square root of 4 is negative 2, since negative 2 times negative 2 is still equal to 4. Okay, so this is still possible. We have 2 possible roots when that happens. So that's when we have an even index and a positive number in here. We would have 2 real solutions. So the first type of question you'll have asks you to find the indicated real root of a. And it will give you information like this. Oop, that's not right. There we go. Okay. The n is equal to 3 and the a is equal to negative 216. So I want to know what the third root of 216 is. Well, we set that up by saying the third root of negative 216. Now I know based on the chart that I wrote in my notes that this is an odd power and a negative a value. So odd index, negative. If it's odd, negative on the inside, then you're going to have one real root. Now, you would either need to type this in your calculator, memorize the chart, or just know that negative 216's third root is negative 6. You can type this in your calculator by pressing 3, and then the button math, and then I think it's number 5. It looks like this. Okay, that button on your calculator, and then typing negative 216. Okay, it will do the third root of negative 216 and will give you negative 6. The next concept in the notes is the acronym No Big Deal FAM, which stands for the numerator goes behind and the denominator goes in front. We are talking about rational exponents, which mean fractional. So, for example, if I had 16 raised to the 3/2 power, I can rewrite this as numerator, which is 3, goes behind. Okay, cool. And the denominator, which is 2, goes in the front. Now, the benefit for doing these, numerator behind, denominator front, is that we can make our numbers smaller before we make them bigger again. I don't know what this is in my head. I have no idea what to tell what 16 to 3/2 power is, but I can do this part. This is easy. I know that the square root of 16 is 4, because 4 times 4 is 16. And then, very easily using a chart or using my calculator, I know that 4 raised to the third power is 64. So knowing that the numerator goes behind and the denominator goes in front, I can first of all rewrite this into radical form or rational form, going back and forth between them, or I can evaluate without a calculator. If we look at one more, the third example on our notes was 9 to the negative 1/2. So to rewrite it in radical form, I would take the numerator, write it behind, and the denominator, and write it in the front. Okay, I don't know what 9 to the negative 1/2 is, but I know what the square root of 9 is. Okay, the square root of 9 is 3. Then all I have is 3 to the negative 1. And my exponent rules from last time tell me that I can't have unhappy exponents. Oh, they're so sad. We got to make them happy by putting them in the denominator and changing the power from negative to positive. But 1 is my invisible exponent, so I only have to write this as 1/3. What? Done. Easy. Okay, you want to use numerator behind, denominator front to rewrite your powers to make the problems easier to solve without a calculator. Now, if you have a calculator or you see the word approximate, okay, I probably can't even spell it right, so I'm going to stop at approximate. If you see approximate, it wants you to use a calculator. Okay, these are things that even if I used NBDF to rewrite, it would not help me. Okay, to do this, all you have to do is type in your calculator 9 up caret 1 divided by 5, and then estimate to the decimal that's asking for. We want to the nearest hundredths, and if you do this in your calculator, you'd get 1.55. Okay, that word approximate means probably you want to use a calculator there. That would be most helpful. Okay, because we know, well, I'm not going to choose a problem that does this, but we can't do the 5th root of 9. That's going to be a decimal. It's going to be 1.55. Not something I know off the top of my head. Let's do one more example like that. We still want to approximate, but this time we have the 4th root of 7 raised to the 3rd power. Okay, I could take the time to type it in like this in my calculator, but that's annoying. So what we do is we use numerator behind, denominator front to undo this. The numerator is behind, so I know for sure that my base of 7 has a numerator of 3, because that is what's behind. Numerator behind. And the denominator is in the front, so that 4 becomes my denominator. I can now approximate this in my calculator to be about 4.30 if I type that in. That's all we've done so far on these notes. I will post another reteach video of the second part of this lesson if necessary. Y'all have a good day.